So I'm gonna just thank you for coming on a somewhat cold and snowy night, where I'm sure lots of snowplows have plowed in people's driveways, and so they could be at home shoveling snow instead of being here. But thank you for coming. This again is a continuing series of things we're trying to do at D2L, which is we have brilliant people that work for us. One standing right there, and we're trying to basically teach the community and the tech community about things that are lessons learned, the things that we deal with on a daily basis that might be useful for other people to be aware of as they're in a startup or they're running their own business or thinking about how to potentially do things differently. So we've learned lots of interesting things continuously about what works and what doesn't work, and so there we go. So tonight's topic is given by the fabulous Michael Squirtle, and he is our database whisperer, for lack of a better term. So he deals with all kinds of things to make sure that we can scale our systems and optimize it and look at for weird, quirky anomalies that might only exist in the depth of SQL's optimization engine, and lots of interesting things. And you're also an illustrator and play around with that. So you're combining those two things tonight to talk a little bit about drawing conclusions. So
exactly.
Thank you, Michael Squirtle.
Thank you. Thanks, everyone. I really want to welcome you guys for coming out today on this frosty December night. The weather isn't perfect. It's not a nice summer fall afternoon, but so I do appreciate you making the trip out here. We're gonna have a lot of fun today. Drawing conclusions by me. So, my name is Michael Squirtle, and I've been working at D2L for almost 10 years. It's interesting what they say about having 10 years work experience. Sometimes they ask, do you really have 10 years experience, or do you have the same year of experience 10 times? I can tell you that working at D2L, the company changes so often. I swear I've worked for a different company every single year. I can stay in one place and the company changes around me. That gives me a lot of variety. It's been a lot of fun. It's been growing every single year. Yeah, so this is me, Michael J. Squirtle, and I added .com in order to introduce my website. One thing I like, when I first got to D2L, I decided to put all of my scripts and all the handy things that I find useful on the internet, so that no matter where I was, I could always go there and look them up. And there's a way for me to place my handy scripts. So one day, 5 years ago, I decided, so I like to write about databases, in particular SQL Server, which is Microsoft's database. That's what we use here at D2L. I like to speak about databases, welcome, and I also like to draw. So one day, 5 years ago, I decided to add illustrations to my articles. And it turns out that a lot of people think it makes a pretty compelling article, because and Microsoft thinks so, and they awarded me the MVP, the most valuable professional. I'm very proud of that. So, what do you need to know for this talk? This talk is a collection of topics. Each topic is taken from a blog post that I wrote. I'm going to introduce an illustration. That illustration is going to introduce the topic. I'm going to talk a little bit about the drawing. It's going to be, and each topic is kind of interesting. Another thing you need to know. Ask questions as you think of them, and I'll take them. Just put up your hand or shout. Now, some of you are in-depth SQL professionals, and if some of this is, you've seen all this stuff before, just wait 5 minutes. I'm going to introduce another topic in another 5 minutes, and that'll be fun. I'm looking at you, Sean. On the other hand, you don't need any prerequisites to be in this room. So if a lot of the topic goes over your head, just wait 5 minutes. I'll be introducing another topic. Looking at you, Nick. So, here we go. first topic. Sorting out execution plans, seeks, and lookups. Just first a bit about this illustration. Adobe Illustrator is the tool I use to do my art. And this week, I played with the 3D extract and bevel tool, and I've never used that tool since. But you see how the icons look a little 3D? That's what that tool is. These icons are icons that you might find in an execution plan or a query plan. Execution plan is Microsoft's way of displaying what it has decided to execute a query as. So a query, yes, SQL Server for some data. It figures out how to get it for you, and it executes it and gives you your data. There's a million different ways to actually decide to give you your data, and its job is to find the best way. In order to ask, in order to understand how Microsoft does that, you can actually look at a query plan, which can describe how it ran your query. You don't need to understand that quite a bit because we're getting into that now. And I'm going to use, as an illustration, the papers that you almost sat on, right? Pick one up and take a look at the white side, right? This, it represents the table, right? The table is Hollywood stars. I just took a list from Wikipedia of people, movie stars, that have Hollywood stars. And I gave them a fake age, a random number between 0 and 100, right? So there are some people, some people whose ages are way off.
Antonio Banderas is 1 year old.
Yeah, is that right? It's the young Antonio Banderas. All right. So this exercise, what I'm going to ask you to do is answer a question. I'm going to ask you an English question. It's not going to be SQL. And I want you to shout out the answer. All right? And I'm going to show you what that looks like from SQL Server's point of view. So this exercise is about thinking like the SQL Server engine. All right? Here's the first question. How old is Tom Hanks? 44. 44, okay. How did you find him?
It's right beside his name.
Right. So the thing is, you found his name because you noticed that it's sorted by last name. You just looked it up. So when we translate this to SQL, it's select age from Hollywood stars, where given name is Tom and surname is Hanks. That's an SQL query. Now, the query plan looks like this. We have clustered index seek. This thing you're looking at has all the data and it's sorted. That makes it the clustered index. And it's a seek, which means we know where to start looking. You just look at H for Hanks. There it is. And it's got two operators. One is the seek, one is the select. For some reason, SQL Server divides the step of fetching the data and sending it back to the user in 2 steps. That's why we get this. Data goes from here to there. Okay. Here's question number 2. It's going to be harder. I want you to try and do this looking only at the white side. Question 2. How old is Zachary?
48.
48? How did you find Zachary?
Got really lucky.
You got really lucky. The technique is, though, that you have to scan Zachary Scott, just to help you guys know that. The trick is you have to scan the whole thing looking. It's like a Where's Waldo puzzle in order to find this guy Zachary. And when we ask the same question of SQL servers, it gives us the same, and it's not a clustered index seek, it's a clustered index scan. That's what it means. It starts at the beginning, it says, is this Zachary, is this Zachary, is this Zachary, until it finds Zachary, that gives the age. Take the data, send it back to the user. Great. That is the difference between seek and scan. You may understand. Go ahead.
Does it require that the last name be unique in order
No.
to
In
accomplish?
fact,
I
if
got
there
the
are two
top names.
people named Zachary, 2 rows would be returned as a result. So
And
it's
if it's
not.
on seek, does it return both Hanks?
Yes. So, great question. If we can seek when we say seek, it's not necessarily need to be 1 row. When we say that SQL Server seeks for data, all we're telling it is it knows where to start. It starts at HA Hanks. So if I were to ask you, here's a phone book, give me all the people with the last name Swart. You might have 3 or 4 people in Kitchener, but you wouldn't know where to start. So that's a seek.
They have to know where to stop.
And when you get the exact, and SQL Server is smart for that too. So that's the difference between a seek and a scan. A seek, you know where to start. A scan just starts at the beginning.
So it doesn't do a binary search?
Yeah, to get to, that's right. So what I'm not showing you is that there's this kind of index, this balanced tree structure that actually helps you get to the first row. So it knows where to start, and it's usually about 3 hops. It knows exactly where to start. It's not seek is very, very efficient. Now what we're going to do is to help out different questions. Because we discovered that it was difficult to scan, we're going to create a non-clustered index. Okay, non-clustered index is like you'd think an index in the back of the book. It helps us look up data in the real data a lot easier. So that's the black side. The black side is a non-clustered index. It has names sorted by first name. All right. This is going to help us out. It's going to help us out with our next question. Who are the teenagers named Bob? Use the black side, the non-clustered index, and the white. Who are the teenagers named Bob?
Bob Hope.
Bob Hope. Any others? No. Bob Kane is not a teenager. He's 70-something. All right. Here's the query. Select given name and surname from Hollywood stars where given name is Bob, from age between 13 and 19. That's the query. This is how SQL Server executes it. It does a seek on the non-clustered index. That's looking at the black side, finding all the Bobs. There's 2. But then it does a key lookup for each of those rows to find the age. This is pretty natural, and you kind of get a sense of what's going on here. This loop just means for each Bob, look up their age. All right. If any rows are returned, return Bob Hope, who is nowhere near. He's passed away by now, but he was nowhere near a teenager for as long as I can remember. All right, question 4. This is not a quiz, but it's something to think about. For the following 2 queries, which is better, a seek or a scan? All right. Find the people where their given name is alphabetically later than you. That's going to return a very small set. In fact, there's only 1 person. Our friend Zachary. The other question is, give me all the people from Hollywood stars where the given name is after Alec. Well, that's almost everyone, right? So I would say that a seek is probably appropriate to find Zachary Scott for the first one. And a scan is probably appropriate. Just start at the beginning, give me everybody, except for the people who happen to be before Alec.
Which field is indexed in this way?
In the primary key happens to be on surname.
Is there any other index on these
Yes.
table?
The non-clustered index, which is
Because I was
That's okay.
a bit late. I missed the beginning. Sorry.
That's okay. Surname is the primary key, or the clustered, I mean. And the non-clustered is the black side. So, I would say this one is appropriate for a seek, and this one's appropriate for a scan. But it's the same query. How is SQL Server going to pick between them? Turns out it knows anyone. SQL Server is smart enough to pick a seek for that guy and a scan for that guy. It does this because it knows something about the data already. It knows, it creates these objects, or these entities called statistics. And statistics are just histograms. So in our database, we have something that looks like that. And it knows if I'm looking up people alphabetically later than Yule, there's only one person. And they can make choices based on these statistics. So, it's important to have statistics, it's important, and SQL Server manages that for you. And it's important to keep them up to date.
It's generating these statistics for our specific database, or collecting that kind of statistic overall somewhere?
Well, these statistics are generated automatically. So I create the table, I insert some rows. Without having to worry about this, I say, select people later than Yule. SQL Server will say, you know what, in order to pick the best plan, I need these statistics. It discovers those statistics aren't there, and it decides to create them on the fly. Does a sample of all the rows, creates this histogram, and then, only after it creates that histogram, it creates the best, it chooses the best plan for itself. It generates all these candidates for an execution plan, assigns estimated cost. The estimated cost is based on what it knows about the data. And then it picks the best plan that it thinks is going to be the cheapest. It does this in a fraction of a second, and you get your data very quickly. All right? So, that is query plans. Query plans aren't always that simple. Here's some typical ones from work. You've got a sort in there, you've got a couple filters in there. Here's a particular variable. You can see that's pretty complicated. What do you notice about this one? The obvious thing, Sean.
Really thick lines.
Really thick lines. It's indicating this diagram is indicating to me that there are millions of rows passing through each operator. And that gives me something to work on. So this is what I work on every day. Now you get a sense of what query plans are and their outcomes. Right? Did you enjoy that? Maybe one more. Go ahead.
How do you know about this scan or seek, this internal stuff?
How do I know?
Yeah.
Everything I told you is in the book, and I read a book. I don't remember the book or an article.
I was thinking maybe there is a tool that can show you.
Yes. Yeah. So, sorry. All these plans are taken from SQL Server Management Studio. SQL Server Management Studio is the tool that I use to execute queries in my day-to-day development. That tool shows you this plan, and it's got lots of features, lots more information. And say, I'm curious about a table school. I can Google, what is a table school? No, lots of people are talking about it.
So other than admiring the pretty diagram, what do you do with the information?
Right. So someone complains about a query, I collect the query plan. Now I can understand why it's slow. If it's a simple with small skinny arrows, then maybe it's blocked. Maybe it's not doing a lot of work. Maybe it's slow for some other reason. If in this particular example, I can see that a lot of rows are coming out from here, and I can ask why. I can ask, do you need all the data you're asking for? I know not to look at these guys because only one row is coming out of them, for example.
seek applies to how you look into the hash table or index table, or
Index.
applies to the table itself.
Okay, so
Are you seeking record by record, or you have
A
so
seek.
basically, does seek apply to index fields or unindexed fields?
indexes. Turns out that all the data is indexes. This white side is a clustered index. It's called an index, but really it's the table. This is the data. There's no data elsewhere. The clustered index.
Basically, the search is always seek is basically the sequential search
Yeah.
in the table.
That's right.
So
And so is a
you
scan.
don't use hash table for indexes
No,
to direct access.
no.
That's going much faster.
If you say so.
But
There
Just
are
opinion.
in memory.
if your index table is sorted on keys, then binary search would be pretty fast. But the hash table is easier to maintain. You know, instead of every time resort or merge
All
your
right,
keys.
we'll talk about this later.
Oh, sorry.
But I'd be curious as to why you think so. All right, we'll talk about it later.
What's the difference between an estimated and an actual execution plan?
Great question. An estimate, you know how I told you that SQL Server creates these candidate query plans to
Right.
execute? And it assigns costs to them in order to choose the best one. The estimate, when it uses statistics in order to assign the rows it thinks are coming through, that's the estimated plan. Now, if I actually run it and say, SQL Server, as you're running it, keep track of how many rows actually did go through. It's just, an actual plan is exactly the same as an estimated plan. It's just that the actual plan has the numbers that
So that-
actually happened for one particular execution of that query.
So the plan that has been used is the one that the engine decided ahead of time doesn't
Yes.
change from estimated. It's just the cost of it, I guess, or
Right, it has extra statistics attached to it, and
Okay.
that's what makes it an actual plan.
okay.
Great. Let's do one more, all right? How many stars are 0 years old? Don't do the work yet. I'm gonna need some volunteers to help me. I'm gonna split up this work. I've split up the columns. You count how many people are 0 years old? How many people are 0? How many people are 0? All right, I've
From the black side or the white side?
from the white side.
Black side.
The black side doesn't have ages.
So everybody is zero. No,
How
everybody
many?
on them.
2?
3.
3?
3.
0.
None.
3.
3.
1.
1. Okay. We have 9 people. See what I did? I took a tricky problem and I split it among my friends. All right. SQL Server does the same thing. This little double arrow says it's parallel. Cluster index scan. Everyone looked at all the rows. Stream aggregate. In this case, the aggregate is count. You guys counted the people that match that filter. Parallelism, gather streams. That's what I did. All right, I gathered the streams. I gathered the answers that people had. And then I aggregated them. I didn't count them. I summed them. When I added them up, get the answer 9. And I'm telling you 9. All right. So that's what SQL Server does when it uses parallelism. All these icons are easy to understand. You kind of know what they're doing. Go ahead.
Why does it keep reading from right to left?
Very good question. It's just convention. It doesn't have to be. The request starts here, and it asks, can I have some, like in actual execution? The request starts here. It asks this operator, can I have the next row? It's like, it needs the next row, etc. This parallelism has to wait for everyone. It's just convention. There's no real reason. All right. I feel we're done with that one. Let's go with the next one. Success, 90% hard work, 10% coffee. I like this picture because I was playing with gradients and textures for the first time. That was pretty good. This diagram comes with I drew it at the same time that I wrote an article called Swartz Rule. I get a lot of people asking me these crazy questions. So for example, how many indexes does SQL Server allow? If you're asking that question, maybe take a step back and wonder. So because of this, I developed Swartz Rule. Microsoft is pretty accommodating when it comes to the things that it permits. So here's Swartz Rule. If you're using over 10% of what SQL Server restricts you to, you're doing it wrong. There's lots of room. If you're kind of bumping up against the edges, maybe you're doing it wrong. Now, this rule doesn't apply universally, but it's fun to think about as an arbitrary line in the sand. So let's see a couple of examples. Batch size, the size of the query, that select star, size of the query, you're limited to 260 megabytes, a quarter of a gig in your query. 10% of that is 26 megabytes. I would say that Swartz Rule applies. Go ahead.
Sorry, is that the length of the query string? That's
Yes.
the length at the top.
Yes. You should never get anywhere near 26 megabytes. If you are,
That's a really complicated.
people do ask this question. If you are, there's a chance that data is sneaking in there. Like you're creating a query that contains data in it, and you're kind of blurring the line between data and query. And there's techniques to avoid that. So people do this. Like here's this XML string, which is crazy long. Databases per server, 32,000 on a box.
You've been asked that?
Yes.
Oh my god.
Well, one of our test servers, which creates and destroys databases all the time. I checked today, it's getting up to about 1,000. It's not violating Swartz Rule, but it's, I don't know, I think 32,000 is quite accommodating. Nested trigger levels. That's a trigger causing a change to a table, which executes a trigger, which causes a change to another table. You're only allowed to do that 32 times. I'd say I'm comfortable with 0. Just to say. 3 is way too much because, again, if you're using a trigger anyway, there are some rare use cases where they're fine, but as a rule, they cause more problems than they solve.
What about number of tables per database?
Do we have that?
No,
No, we don't.
Do we have any limit on that?
There probably is, but if you're reaching that limit, you're probably doing something crazy. There's no restricted limit. Procedure parameters. 210 is a bit excessive. Database size, 52 petabytes. You were probably, if you're wondering about this, you're probably going to encounter other problems before you get there. Now this is an interesting one. I personally think Swartz Rule doesn't apply to identifier links. These are the names of objects, tables, procedures. 12 is a bit restricted. The word registrations has 13 letters in it. I think that's just fine. This, from experience, the longest table name at work is Manage Courses Widget, My Courses User Collapsed Groups. That's a mouthful. Thank goodness for IntelliSense. Longest column name, background image position, horizontal custom value. They're storing CSS in the database, which is kind of weird. Longest procedure name. The last time I gave this talk, that number was 88. I had to update this. SLE Dropbox entity submissions, fetch submission entities by user IDs in Dropbox 1054. That's too long. There's a lot of stuff in there.
You know when that becomes a problem, right? Is when it's packaged in something that
Gets that added to
Exactly.
a directory name or something.
Exactly. Turns out, if this identifier was up to here, you would hit the limit, which is crazy. It's a bit too verbose. All right. Anyone recognize this guy?
Oh, yes.
Yeah.
That's Malcolm Reynolds, played by Nathan Fillion, as in Firefly. He's a space cowboy, which is great. I like this picture because it's using 2 different light sources. I think that works well. This is attached to a query called, a blog post called "Does Join Order Matter?" Talked about what can you do about database performance. Well, there's very little you can do. And so a lot of people wonder about join order. In this case, look at the only difference between these 2 queries is the order of joins. Users join orders versus orders join users. Well, so the question is, which performs faster? That's a trick question. Joins are commutative, and SQL Server knows it. Commutative is a math term, and it just means that A join B is going to be the same as B join A. Here's proof how SQL Server knows it. Go ahead, Alcy.
The only problem with yes, they're the same, but if the plan doesn't recognize that and it looks at the table first that has more rows, it'll be slower than it looks at the table first that has less rows.
Right, but remember when I said that SQL Server evaluates all the candidates of query plans? It will evaluate both. In fact, here's the query. It says, users inner join orders and orders inner join users. We're all familiar with query plans now. And look how it used orders join users. And it's the same query plan here, orders join users. It swapped them both and evaluated both and chose the cheapest one in both cases. If it picks different ones, because maybe it didn't have time to evaluate both all, or it thought that they were both fine or good enough, these sort of things.
Is this true when you express the join in the where clause? Like select from 2 tables where and then
Yes, entirely equivalent. So,
it's mixed with other Boolean predicates.
yeah, it's all there, and what it does is it creates this kind of tree of your logical query, and it translates that to query plan candidates. So when it creates that, they are equivalent, no matter how you put in the where clause. So the order of this stuff doesn't matter. So quit your fussing. Don't worry about the order. There's other techniques for performance. It's not, you're not going to get better performance based on the order. All right. This is a story. It has nothing to do with databases. In a previous job, I once had someone ask me a question in an interview. It's kind of an HR interview. I don't know what the purpose of the question was. I just remember, Graham, what do you remember?
I know the purpose of the question.
Okay, we'll talk about it. So there's a cow in a field. You're a farmer in the field, and you notice that the fence is busted. You need to go back to the barn to grab a nail to fix the fence. How are you going to do that without the cows? Right, this is the problem that I was posed to me. Answering, I answered, I don't know. I just go back to the barn. Cows are pretty stupid. That cow will still be there. Like, no. The cow will escape. It's like, they're not velociraptors. I've worked with cows. Cows are very stupid. And then the interviewer said, oh, you're a problem avoider. I took a little bit of offense to that. Problem avoider. So I thought about this over 10 years and thought about it. I am a problem avoider. I'm owning it. I hate problems. Who likes problems? I avoid problems. That's not to say that I don't take responsibility for issues that show up, right? So, case in point, if someone comes to me and says, how do I make this perform really fast on this table? Well, one question is, how many rows are in that table? Oh, it's a table of provinces. Right now there's 10. Don't bother with me, just check it in, move on to the next thing. Problem avoided. Because another way is, someone says, how do I get a list of all the users? Well, why do you want a list of all the users? If they don't have a valid, or just cache that data, if they don't have a valid, if there's a way to avoid that, it's an effective way of dealing with that issue. I guess it's avoiding problems. It's addressing problems, but still taking responsibility by avoiding them. I'd love to hear what the real purpose of this is.
So the actual question that comes out is you're fixing the fence and your hammer breaks.
Your hammer breaks.
And the head of the hammer comes off.
All right.
And it's how do you deal with fixing the fence? You have another hammer back in the barn.
Okay.
Go get it, the cow will get it.
No.
But what it comes down to is how do you solve that problem? So some people will try and put the hammer on it.
Sure.
Some people will try and use the head of the hammer. Some people will find a stone. And you can learn about how people think and how they problem solve by that. Some people need the right tool or they can't do it.
Okay.
Whereas other people will find whatever tool, whatever will make it work. And then there's people in the middle who are looking for, well, this is the right tool, but it's broken. I'm going to make it work anyways.
Okay. So it's about using the right. The real question is about a broken hammer and how do you deal with using the right tool or affecting the. So this diagram was a bit of my passive aggressive way of, it's like, this is a static picture. Anytime you look at this picture, that cartoon of that cow, I even did the tongue and the eyebrows. That cow is still going to be there because it's a cartoon. So if you come back later, this cow will still be. Okay, back to SQL Server. A timeout always represents server unresponsiveness from the point of the client's point of view. Question, what is SQL Server's default timeout value?
32 minutes.
Is it?
What's that?
There isn't one.
There isn't one. It's a trick question. SQL Server doesn't have a timeout value. SQL Server is more patient than anyone. There is no timeout. It will keep plugging away at any query you give it as long as it's got its power cord connected. So for example, anytime we see a timeout, it is a timeout that is initiated by the client. In our C# apps that we use the ADO.NET client. It's the ADO.NET client that has a 30-second default timeout. So when 30 seconds are up because something is too slow, the client tells the database, this query, never mind, I don't care anymore, and it throws an error. So it's always from a client point of view. A lot of people, this question comes up when the assumption behind server-side timeout comes up when we want to actually adjust the timeout at a server level. That's not a thing.
Not even when the table is locked, right? You send it.
If the table is locked,
yeah, then
then one query will wait. It'll wait forever.
So if they have a bad process written badly, can lock down every other process on the whole system.
Yes, and that's a problem that we work hard to avoid. It's a fascinating. This is what makes my job very interesting. Avoiding stuff like that. This is guts of the actual communication protocol between a client and a server. You can get rows back bit by bit, and as long as they're not 30 seconds apart, the stopwatch is reset. So if you get a trickle back of data, your ADO.NET client seems more patient than you might expect. And it might explain why, where you're used to 30 seconds, why you might get a minute before you get a timer. So that's that kind. All right. Ted Cod hates that thing you just did. This is the second cartoon I ever drew. And I captured something here that I've never actually been able to capture since. I just like something about it. It's snarkiness. Ted Codd, he wrote a paper. He was an academic guy in 1970. He published it in 1970 called The Relational Model of Data or Large Shared Database. And he defined what it is, what it means to be a relational database. He published this. It's rare to have something like technology influenced so heavily by something from the academic world. But this is a perfect example. He actually, although it was the academic world, he did work for Ivy University. This is 1970. It's important to kind of understand the context for where he was writing this. When you stored data in the 60s, you didn't have a database. By the way, they call them data banks. I think that's kind of cool. Blood bank, a financial bank, you store things in there. Data bank makes sense. Database doesn't make as much sense as data bank, but here we are. So, 1966, you store your data in something called IMS. IMS is a database based on hierarchy, basically a file system. You had folders. I don't know if they call them folders, but you had a hierarchy of data. And IMS was developed for use by NASA when they were developing the Apollo program. That sounds really cool, but it turns out it wasn't used in the rockets or anything. It was used for the bill of materials for the rockets. So it's like the coolest project and the dullest piece of it. This is the database world. But it was stored in a very specific way, and it had to be stored in a way that you knew ahead of time what you were going to ask of it. If you were going to ask of it, how much aluminum, if you were going to ask of it, what pieces do I need for the lunar lander? It could tell you that. How many bolts do I need for engine number 2? It could tell you that. But if you then all of a sudden asked it a new question that you didn't design for, how much aluminum do I need for the whole thing? That's a different query, and that's going to be very, very difficult. It's something that a hierarchical data store can't deal with very well. Then along comes Ted Codd, and he developed the relational model. It was an academic paper before it was anything that you could buy or use. So in 1970, it existed as an idea. And you need to talk to it. So he called it SQL for a couple of reasons. Structured English Query Language, short to SQL. SQL because it was the next thing. Turns out though, SQL was already trademarked. So he turned it to structured query language. But we still call it SQL. It's supposed to remind you that it's the next best thing, even though this is before I was born. Then people took that relational idea and they built products around it. Oracle by Oracle. DB2 by IBM. There is no DB1. DB1 is IMS. Again, DB2 is IBM's first relational database, but already that 2 is supposed to remind you that this is the next best thing. I think that's really cool.
Data bank 2?
Data bank. No, database 2. I think by the 80s they had gotten rid of.
Is it true?
I don't know. Sure, data.
Is it true that Ted Codd worked for IBM and presented the paper idea first to IBM and they rejected it?
IBM didn't know right away that it would be as useful as it proved to be. Relational databases dominated the 80s and 90s. So what makes it so powerful over the existing thing? Well, let's take a process. I'm going to show you some hierarchical data. This is a directory. All right? This is JSON. JSON is hierarchical, but it still counts. This is a directory of people, their IDs, and phone numbers. These are not real phone numbers, so it's okay, Nick. If we want to make a relational, when we talk about the relational model, relational doesn't talk about relationships. Technically, it's about relationships between columns. Each row inside it. Relation is a synonym for table. So let's stuff it in a table. This counts as relational, but it's not an improvement over what we had before. Because if I want to delete Nick Odson, what happens to this phone number if we were managing phone numbers, for example? If I wanted to delete a phone number of mine, that is an update statement, not a delete statement. So it's kind of weird. So in Ted Cott's paper, he defined these normal forms. If you follow these normal forms, you get this powerful kind of data model that avoids a lot of problems. This is first normal form. First normal form means when you store a piece of information in a cell, store only one thing, one and only one thing. Right? This is why we have 2 phone numbers for Michael Squirtle. You may notice that I spelled my name wrong. If we were to update this, there's nothing in the model that would prevent me from accidentally, there's nothing about the database that prevents me from accidentally correcting one name, but not the other. That is called an update anomaly. It'd be inconsistent data. And we want to keep this data in sync because they do refer to the same person. And so that brings us to second normal form, where we have 2 tables. Now all of a sudden, if I wanted to change my name or fix a spelling mistake, I do it in one place. We get consistency, and we avoid redundancy. This solves a lot of different problems. It also means that I can store people and I can store phone numbers separately. I can have people without phones. I can have phone numbers without people if I just decide not to store it. That 1 to 3 helps the cross-referencing. Now all of a sudden, I can use SQL to ask questions about the data that I never had when I modeled the data first. All right, next topic. This is how I feel. At D12, we worked really, really hard in order to avoid downtime when we're updating the database. All right. So our migrations are live. Clients are using our system. They're taking tests. They're writing quizzes. They're participating in discussions. And we changed the product. And this is a picture of Indiana Jones. I really like how it makes me feel, because he's very nervous and he's trying to replace it with something just as good. And I worry that a big boulder will crash on him. So far, so good, no boulders. All right. Most people, without this kind of what I'm going to call a blue-green process, this online migration process, accept downtime when they want to upgrade their system. Bare bones system looks a little bit like this. Users are using web servers which make use of databases. Originally, our upgrades look like this. We stop the users, we create a maintenance window. We replace or change the web server, so it's green is new. We change the database, then we bring the users online. Straightforward, but it has an outage. This is how we do things the blue-green way. Blue is the original server, green is the new server. So the idea is to separate database changes from web server changes. We decouple them. And we never want users to not have always want users to not have an outage. First thing we do is we run a pre-script. This is, we're going to have two scripts, pre and post. Pre changes the database to what we call an aqua state. All that means is what the database is now backwards compatible and forwards compatible. The database is ready to serve blue servers and green servers. It doesn't, it only serves one at a time, but it's ready to. After we do that, we switch. This green server is a brand new server. It's virtualized. We've changed the load balancer to point to the new servers after everything's hunky-dory. Then we run, that one's no longer needed, so we get rid of that guy. Then we run a postscript to clean up everything. And there we are. We have, the thing is that this is a lot more complicated. It's got a lot more details to take care of, a lot more places to go get things wrong. But if you get it right, no more downtime. And that is very, very valuable to us. Because there's so much going on here, automation is very, very important. Everything is done by scripts. No one's running Management Studio hitting F5. Everything is done automatically. We have automatic checks, automatic health checks. We have automatic checks to make sure things are backwards compatible and forwards compatible. That our migration scripts bring you to a place that's going to be the same exact thing as if you were to get a brand new install. All these things are very, very, it's a good job for a detail-oriented person. It can be really fun. That was our blue-green update. Questions about that? Because it was fascinating to talk. Yeah.
So did you run the SP rename?
Yes.
Oh, okay.
That was the original one. That was the blog post for the Indiana Jones article talks about a very, very specific way to make changes into a database that maintains that uptime. I'll give you an example right now. The changing a column, the original script looked like this. We use SP rename, store procedure, rename. We're going to change the column title in the news table. We're going to rename it to headline. Right? This is the script. It executes automatically, except it's not blue-green saved, which is too bad because this is a very simple script. This is what it looks like in the blue-green one. This is pre. What we do is we create a new table, or a new column, headline. We add a trigger to keep them in sync, headline and title. And then the new people come online. We finish syncing. This is the postscript. We finish syncing and clean up after ourselves. It's a little bit more work, and I don't like triggers to begin with. And so you kind of get your hands dirty, but in order to accomplish a goal.
Did you have a scenario when the green web server failed?
Sure, when green server failed, but we do have health checks so that we know that if we're not ready, we have these automated checks to, it's like a test suite that makes sure the green server is ready to accept connections and do all the work. And when we're ready, only then do we switch over to green. Also, if things do go bad, there always is the option to go back to blue. We haven't had to do that. I don't know if we've ever had to do that, but that was always a safety option.
Plus stuff extended on the state for more than a day.
That's right. This trigger, exactly. We've been in the aqua state for more than a day, as Nick said, which can be tricky because you know this when this trigger is meant to be there as a stopgap. It's like riding a spare tire cross country, right? It's not really meant to be the thing you use.
When you change the server, you upgrade the server, right? So the
Yeah.
data should remain intact, or something else
Yes.
changes. So if the data is intact, what's the need to change the column names? Why you need to?
Column name was maybe a bad example. Another one is addition of a column. We might
Yeah,
want to
but
do
the
that.
data is still the same.
Yes.
So you change the server, that means somehow the interface with the user, I assume, stays the same. So you gain something of performance. What's different from the old server to the new server? What
Right.
changes?
Right. So in our case, the application and the database change at the same time in order to add new features, in order to add new functionality. And for that, we may have different needs. We may need to store data for different purposes. And so they change together. So in other cases, you might have a database with many different applications, in which case the data schema is going to remain very stable. But we actually embrace the kind of modifications that allow us to add new features.
So basically you change the implementation of the data while you're switching servers.
Yes.
So nothing user should be concerned about, but the data actually changes, but it's transparent to the user.
Yes. So we don't have huge overhauls of data. We never do anything like that. But it can be awkward. Sean, you know this.
I was going to say instead of call and name changing, but sometimes you have to expand your data type, like int to make
Correct. As Sean, another great example is when I have an integer which is too small and I want a big integer. That's another example. All right, that was blue-green.
I just want to make a funny point. It still requires more discipline on the development side because even it's unlikely, but if anyone actually wrote code that was by ordinal position, even what we did,
Correct.
It's
Correct. Sean points out that the entire development organization has to tread lightly. If you count on column orders, so that age is the third column, and I'm expecting the third column to give me the number I'm looking for, that may not be true if you do stuff like this. Who recognizes this guy? This guy's Geordie LaForge is my hero, and if I'm ever stuck, I ask myself, what would Geordie LaForge do? Because I'm an engineer, he's my, I guess, if this were a leadership talk, it might have something like this. Jumping courage, quite a great leader, but no, this is about Geordie LaForge. Geordie LaForge taught me a way to approach work. So, lesson number 1: make everyone believe you can do anything. That's step 1. There's a quote by him to kind of illustrate what I mean. Card says, "Can you fix the neutrino flux generator?" And Geordie will say, "Yes, I can fix that, Captain. ETA of 30 minutes. All right? Now, this is how it would have gone if you couldn't. "Can you fix the neutrino flux generator?" And Geordie would say, "That can't be done, Captain. The flux couplers aren't in phase." Okay, see what he did there? If he can fix it, he says, "Yes, I can fix that." If he can't fix it, he says, "That can't be done, and here's why." So what he's doing is kind of showing that he can do it, or it's impossible. It's kind of a cheat, but this is something that you see all through Star Trek. Step 2, and you can't leave step 2 out, and then make sure they're right. Make sure you can do everything, and that is the hard part. That's the guts. So, I like another quote from Geordie. or Runker says, gentlemen, we're giving you an assignment. The one thing we don't want to hear is that it's impossible. I need the transporters to function despite the hyperonic radiation. And then LaForge says, yeah, but that's it. Yes, sir. Okay. So the thing is that he came back, like at the end of the episode, says, well, sir, we can do it. It's going to take a team of research scientists and 5 years to do it, but we can do it. It's like, yeah, he's meeting the, maybe not the spirit, but he was given a pretty tough task. That's hard to do, and it means not giving up on a problem, because it's easy to say that can't be done, but you have to be correct. If someone else finds a way that it could be done, it kind of embarrasses you. But, so we do that by being awesome. How does Jordan LaForge be awesome? It's because he cares so much. You can be awesome in 2 ways. You can be talented, you either have it, or you can work hard, like just hard work and perseverance. Think of, imagine you're on vacation, sitting at a beach, and you look over, the guy in the next lounge chair is reading a tech manual on vacation. But are you in a field where you might want to, like that you actually are passionate about? And that's what I like about Jordan LaForge, is that he is very passionate about the thing he does. He likes starship warp engines or whatever. There's a quote that I like. Picard says, wow, warp without warp drive. And Riker says, they're going to put you out of the job, Jordy. And LaForge says, I hope so, Commander. See, he loves this topic that much. And that is Jordy LaForge being awesome. And that brings me to say, thank you very much for coming. I appreciate you all being here. I will take questions now. Or applause first. Questions? No? We're good? Yeah.
Will SQL Server do backwards table scans or seeks?
Yes, it will. That's a great question. Will it seek and go backwards? It absolutely will. It's smart.
Yeah, I found it interesting that it wasn't the example you gave, creative executives.
Oh. You mean the ALEC versus?
Yeah.
Yeah. The difference there was I was scanning most of the table versus a little bit of the table. It was both one way, forward. It doesn't do a seek if its only purpose is to eliminate rows by doing some sort of difference. It doesn't do that. Yeah.
So you have lots of Star Trek?
That's right.
Lots of databases.
Lots of Star Trek and lots of databases.
Lots of databases, but no data.
But no data.
That's character.
That's right. Why? That's a huge oversight on my part. Thank you, Nick, for that totally spontaneous and unscripted question that I in no way asked you to ask me. I actually do have some data cartoons. This is changing data. Changing data. There we go. Metadata. Get rid of redundant data. You can make redundant. I feel sorry for this. You can't cat.
Yeah.
Why go data mining?
And database. This is my favorite part. Thanks, guys. Yeah.
Are you familiar with other databases like MySQL and Oracle? Do they do different these things?
MySQL and Oracle and other relational databases, do they do these things? I'm not as familiar with those, but I do know that they each do the same kind of query optimization as SQL Server does. The technique of generating many different plans, assigning an estimated cost, and picking the best one, that cost base is called cost-based estimation. that technique was not always universal. All the engines use that now. Oracle used to use a rule-based, just these are the rules, and you follow them, and here's your query plan. A lot of the information here that I've talked about today is transferable. And of course, I don't know how to get a query plan, but query plans do exist in the other, but pretty much most of what should be applicable to the other database platform.
When you switch the server, do you do it simultaneously for all users and for all processes, or you group them and do one group at a time or one database at a time?
The question is, when we do that blue-green migration,
Yes.
do we
All the users switch at the same simultaneously, or is it possible for at a given time some processes use the blue one, some processes use the green data server, or all of them switch at the same time?
Everyone switches at the same time. I think there are web server requests that finish, but all new requests go to the new green server.
For all of the same.
Thank you so much, everyone. I think we had a lot of fun. Mike.
I was gonna just ask, maybe I was reading too much into the title of your talk, but if there's ever a time where you're drawing as problem solving,
Drawing as problem solving.
to try and, or if your drawings tell you that your conclusions are either suspect or because database architects, administrators have a tendency to be thoughtful about conclusions that they're willing to share.
Okay.
From my experience.
I think Mike's question is, does my drawing
Does your drawing ever
have
leave?
it ever influenced? Not really. I draw boxes, but that's a different part of my brain.
So it's more illustrative than
Yes.
inferential or something.
Yeah. And I just like drawing Star Wars and Star Trek. These seem to be. It's interesting though, because when I go home, if I'm tired, I'm usually in the mood to draw. But if I'm not in the mood to draw, I could also be in the mood to write about databases. And there are different parts of me get tired at different. So I've always got something to do.
One last thing, what's a takeaway people can leave with about data or databases or optimization or what's the thing that they can take home with them and do differently tomorrow?
A single thing that people can take home and apply just tomorrow. It's a I would ask everyone to just remember that this world is fascinating to me, and I know it can be fascinating to everyone. Maybe not specifically to databases, but there's a large field to be passionate and interested about, and sign me up for this one. Thank you very much.
There's more snacks, so please eat more snacks because I'm not taking it all.
Yeah,